breathtaking moment for astronomy. Scientists have unveiled new Hubble Space Telescope images capturing 3I Atlas, just the third interstellar object ever spotted passing through our solar system. The cosmic stage is set, and as this enigmatic traveler from another star system draws nearer to the Sun, it's revealing clues that could rewrite what we think we know about visitors from the farthest reaches of space. But here's where things get truly fascinating and a bit contentious. At a distance of about 3.8 astronomical units, AU, from the Sun, or nearly 4 times farther away than Earth's own orbit, 3I Atlas is already displaying surprising activity. The Sun's energy is awakening the object, prompting it to release streams of dust. This dust emerges from the part of the object's nucleus facing the Sun, while a faint tail, sculpted by radiation pressure, fans out in the opposite direction. If you're picturing a typical asteroid, think again. This is a whole different beast. Let's break that down. 1 astronomical unit is the distance between Earth and the Sun. So, at 3.8 AU, 3I Atlas is far out in the solar system, yet solar heating is already transforming it. Unlike most asteroids, which tend to remain stable as they orbit, 3I Atlas acts more like a comet. Why the difference? Well, asteroids are usually solid, inactive rocks. Comets, and this interstellar visitor, heat up and shed dust and gas, forming spectacular tails. This distinctive behavior is giving astronomers a rare chance to peek at material forged around distant stars, a true sample from another world. Thanks to Hubble's sharp vision, David Jewett's team at UCLA has made headway estimating how much dust 3I Atlas is releasing as it basks in sunlight. Based on their measurements, anywhere from 6 to 60 kilograms of dust blast off from the object every second. To put that in perspective, imagine a small car evaporating into space every few minutes. For an object so remote and comparatively small, such rapid mass loss is astonishing. But, and this is the part most people miss, determining the object's actual size is a major challenge. The solid core, or nucleus, is cloaked in a bright cloud of dust called a coma, so astronomers have to estimate size indirectly. By analyzing how the coma shines, the team calculated that if the nucleus reflects just 4% of incoming sunlight, as coal does, its radius can't be more than 2.8 kilometers. They also factored in how certain ices like carbon monoxide might be vaporizing. If CO is behind the activity, the object is at least 0.16 kilometers in radius, possibly larger if less volatile substances are involved. Why does this matter? Well, the types of materials that evaporate at different distances from the Sun help astronomers deduce what the object is made of and where it could have formed. Different ices require more or less heat to turn from solid to gas. So by watching how and when the activity starts, scientists can make educated guesses about the nucleus's composition and history. It's a cosmic detective story unfolding before our eyes. Let's not overlook the rarity of these visitors. Before 3I Atlas, only 2 other interstellar objects had ever been identified, Oumuamua in 2017 and Borisov in 2019. Each interstellar arrival is more than just a curiosity. They're time capsules from worlds beyond our Sun, carrying the chemical and physical fingerprints of alien planetary systems. Hubble's data on 3I Atlas isn't just a pretty picture. It's a leap forward in our ability to glean secrets from these galactic wanderers. These discoveries might eventually force us to rethink our theories about planet formation, composition, and even the dynamic processes shaping exoplanetary systems throughout the universe. And here's a controversial angle to consider. What if these objects carry more than just ice and dust? What if they've brought unknown ingredients or processes we haven't dreamed of? Are we prepared for surprises from the great cosmic beyond? What's your take on these astonishing discoveries? Do you agree with the scientific consensus about interstellar comets? Or do you see these findings pointing in a different direction? Dive into the comments below and share your most out-of-this-world theories.